All right, done. Okay, so let's talk about what we learned yesterday, because that's part of today's. We talked about correlation, all right? And you guys did really well with that. That was the first part of the homework. So for those of you that weren't here yesterday and haven't watched the video yet, remember, you should be watching the videos. Correlation is either positive, negative, or neither. And we simply look at a scatter plot. This is a scatter plot, just a bunch of points graphed that has to do with like real world data. And it's graphed for us. And then you actually just say, does it trend to be like a positive slope, or is it like a negative slope, or is it neither? And we saw all those different types yesterday, okay? Yeah. All right, so they're never going to be perfect, like a perfect line with a positive slope or a perfect line with a negative slope, but you should be able to say it's mostly either positive or negative, or there's absolutely no pattern there, so it'd be neither of them. That's what correlation is, okay? I'm going to introduce a second word to you today, which is going to confuse us, because it confuses me when I'm talking about it, because it starts with a C. Yesterday was correlation, right? That was this word. Today's new word is causation. Okay? Causation simply means, does the data on one axis affect the data on the other? Does it cause it? For example, well, let me use this as an example. This is a great example, and I'll give you guys some other ones. So here we have a scatter plot, and the data shows the per capita. Now, guys, per capita means per person. Per capita consumption, eating, of mozzarella cheese. Okay? Fascinating stuff, right? Per capita consumption of mozzarella cheese, that's your x-axis. Okay? And the number of civil engineering doctoral degrees awarded in the United States. Okay? So that's what this is a graph of. Okay. So first of all, let's start with yesterday's stuff. Would you call this positive, negative, or neither? Positive, right? That's clearly a positive correlation. It's like a positive slope. Okay? What I'm gonna ask you now is, does this show causation? So this is what remember yesterday you'd have to say positive, negative, or neither, and if it was positive or negative, you had to give a little statement. So what this is saying is, as I'm gonna just abbreviate, mozzarella consumption increases, okay? By the way, guys, the x-axis is always increasing. So whatever they're talking about here, it's always increases, okay? X values always increase. As mozzarella consumption, the amount of mozzarella that people eat increases, this graph is saying the number of doctorate, and I don't care about spelling or anything, the number of doctorate degrees also increases. That's what this graph is saying. Okay? That's what this positive correlation says. As this gets bigger, that gets bigger. As this increases, that increases, right? That's what a positive slope means. Causation is, does the increase in mozzarella consumption also create more doctoral degrees in the United States? Does that one cause the other? No, it's ridiculous, okay? The amount of mozzarella that people eat has nothing to do with their college education, okay? So we would say this has no causation, okay? No causation. One does not cause the other. So let me give you another scenario. Does the number of hours that you study, so if I just made myself a little graph and I said this represents, that's the scatter plot, it's showing positive. The number of hours you study is increasing. So the more you study, the test grades will increase. So if these are your test scores and this is your studying, so as studying, the number of hours increases for studying, does your test grade and your test grade increases? That's what that would be saying. Is that showing causation, yes or no? Yes, that makes sense, right? The more you study, most likely you will get higher scores. Now, there's always you're sometimes an outlier, okay? So I'll use me, little Tracy Morse in Algebra 1. I study my little behind off. I'm studying 10 hours for a test, and my score is like down here, all right? That's an outlier. Even though I studied for 10 hours, I still only had a low score. That's called an outlier. It's real life data. I can't say for sure every hour you study more, your grade's going to go up. But that's what it tends to be for the most part. That's why you see points not perfect, okay? But could you have one that's not in line with all of that? Yeah, but what is most of the data saying? Okay, so that's really important. So a lot of what we're doing today is more common sense. You won't pick up your calculator one time, right? That's kind of nice, right? It's more about understanding what it's asking. Let's look at another one. Now, we're on the check. So notice the notes are almost over. We're already at the homework on the next page, okay? So it's very short. Determine whether there's a correlation between the variables in the data. If there is a correlation, does this mean that a change in sunscreen sales causes a change in sunglasses sales? Explain the reasoning. Okay, so let's look at this XY chart. It's got 3 rows. So really, you don't look at the top one. This is just saying when it happened. So they looked at March, April, May, June, July, August. But what we're really looking at is this is our X, this is our Y. So notice, look at your X values. So we don't have a scatter plot, right? We just have the points. You don't have to make a scatter plot. We're going to just sketch what we think the line is doing. So just make yourself that quadrant 1 real quick. Oops, sorry. Make yourself a little quadrant 1. Guys, what are the X values doing? Are they increasing or decreasing? Increasing. And they're always going to be increasing. Okay? So the X values are increasing. Again, the X values will always be increasing. It's really what the Y values are doing that can change. They'll either be mostly increasing or mostly decreasing. So if you look, we have 6, 11, 28, 36, 40. Okay, we went down a little bit here, but for the most part, would you guys say increasing or decreasing? Increasing, right? So what does that look like in a graph? As X's are increasing, Y's are increasing, that would look like a positive correlation, right? As X's get bigger, Y's are getting bigger, okay? So this does show a positive correlation. As the number of bottles of sunscreen, so here's our sunscreen, here's our sunglasses. Very informal graph, okay? As the number of bottles of sunscreen sold increases, the number of sunglasses sold also increases. That's what we said, right? Does buying sunscreen cause people to buy sunglasses? It doesn't. You know, so this is, sometimes these can be a little confusing because you're like, oh, sunscreen, sunglasses, that goes together, summertime, you're buying both. But because sunscreen sales are going up, does that mean sunglasses sales are going to go up? No. Okay. And there's going to be, sometimes you might disagree with me, and you are more than welcome to say that. And we had some really good discussions in my first period class. And we actually, there was one we did in a minute that we kind of decided we were going to say maybe. We could make an argument either way. And I could see where somebody might think that there is a correlation here. Okay, so buying sunscreen does not cause people to buy sunglasses. Both items are likely in higher demand in the summer months, which may influence both variables to increase. Okay, it makes sense that they're both increasing, but one doesn't cause the other. Okay? All right. Does the correlation in this situation illustrate causation? Okay? So listen to this next scenario. A university experiment showed a negative correlation between the average weekly time spent exercising and the probability of developing heart disease. So here's a negative correlation. So let's just make our quadrant 1. You guys, we learned yesterday what a negative correlation looks like. It's like that, right? You'd have your data points looking somehow showing negative, okay? And what is it again? time spent exercising How do I know that's the X? Because it came first in the sentence. That's all. Between the time spent exercising and probability of developing heart disease. So let's talk about that. As time spent, so the more you exercise, right, because X's are always increasing. As you exercise more, your risk of heart disease, what happens with it? Goes down, decreases, right? That's what that means. As we increase our exercise, our probability of getting heart disease gets smaller. Does that show causation? Yes. One does cause the other. We know this. I mean, you guys are young, so your doctors aren't talking to you about stuff that my doctors are talking to me about. You know, as we get older, you know, it's very important to have a healthy heart and eat right and blah, 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 right? You may not be thinking about that, but I think it's common knowledge, right? Exercise is good for the heart, okay? So the more you exercise, the more healthy you'll be, right? So a change in the amount of time spent exercising does cause a change in the probability of developing heart disease. A lack of exercise, is, I think it's supposed to be, is a cause of heart disease. Other factors, and I feel like this is dumb, but they have asked us, this is not a health class. Don't have to know this, but like smoking, poor diet, things like that, okay? But don't worry, that's not going to be on the test or anything. Okay? So what we're going to do is our homework right now, which is going to be answering some of these questions, okay? So I'm going to do the first one with you so you know exactly what to do. Now, before I do that, and maybe let's go to I guess you're already on the homework page. I want to tell you guys, Monday, well, let me back up before I tell you the homework. We're on page 241. Monday, like you have a sub, so I won't be here to collect from you. But we did a lot of work this week that I will be collecting on Tuesday. So on Tuesday, this is what I'll be asking you for. Pages, it's all in the workbook. And if you wrote on a separate sheet of paper, right? 217 to 242. That's what I'm collecting on Tuesday. That is 4.2. We did it for 3 days, Monday, Tuesday, Wednesday. Yesterday we did 4.3, and today we did 4.4. So you have you'll have a lot of time left over when you're done with the assignment that I'm about to give you. Maybe you go back through those pages, you get on Canvas. Guys, the other Algebra 1 teachers don't post their notes, they don't make a video. I do all that for you so you can stay caught up. Please use it. Canvas is your friend. It's your friend. Okay? All the notes, all the homework is there. So that's what I'm collecting on Tuesday, so there will be no surprises. Now, Monday, don't forget, every Monday, EDIA is due at midnight, and there's always a new one. So, like 5 of you have done your EDIA assignment. That's due Monday. Work on it today. Work on it on Monday when the sub is here, but make sure it gets done. I won't be here to remind you. I did put it on the sticky note on the key for the sub to put up, but just make sure you don't forget. I'm not doing makeups on it because I give you time in class to work on it, so I need you guys to be getting it done. Okay, I'm going to do number 1 with you so you can see exactly what you're doing here. Notice they didn't give us any scatter plots. We have to be able to look at the numbers in the charts to answer the question. So let's do number 1 together. Everybody? The table shows the number of pounds of frozen yogurt and the number of pounds of sherbet. Do you guys know what sherbet is? I've always said sherbet, but there's no extra R in there, so it feels weird saying sherbet. It's like another kind of ice cream, but it's fruity. Okay, but just whatever. Table shows the number of pounds of frozen yogurt and the number of pounds of sherbet consumed per capita, how much they ate per person in the United States for some certain years, okay? And so here's our pounds of frozen yogurt, pounds of sherbet, okay? So what we're going to do, we're not going to actually graph those points. we're going to literally do what we did in the notes. Just draw your quadrant 1. This would be yogurt. This would be it. Very informal, no stressing about it. And let's see if it's showing positive, negative, or neither correlation. So look at frozen yogurt. 0.91, okay. Just like my teacher said, the X's are always increasing. Okay, they're always going to be getting bigger. Because we read a graph left to right, so they have to be increasing. Okay? Now, here's where you have to make a decision. So look at what's going on here. 1, 1. So that stayed the same. We went down, down. We went up, stayed the same, down, down. What do you think you would call that? Would you call that increasing or decreasing? It's more decreasing than increasing. Okay? So it's not going to be super clear. It's not going to be like 10, 9, 8, 7, 6, 5, 4. All right? You have to make an educated decision. So what that means is, as the X's get bigger, the Y's get smaller. That's negative correlation. Okay? So that's all you have to do for the graph, is just show either the positive or negative. Jace, why are you writing this? Are you writing this? Okay. Determine whether they're correlation. No, remember, don't get the words confused. Correlation is positive, negative, or neither. Right? So this would be negative. Right? That's showing negative, like a negative slope. And you're supposed to explain it as, what are we doing here? As yogurt, and sometimes you just have to go back up to the question and kind of grab the words. What is this dumb question about yogurt consumption? As yogurt consumption increases, sherbet consumption, what? Decreases. Right? That's what we did yesterday. So if you weren't here yesterday, we did looked at a bunch of graphs and had to say positive, negative, and then what it was showing. Okay? So if there is a correlation, and there is, does this mean that a change in frozen yogurt sales causes a change in sherbet sales? I hear yes. Is there a no? Anybody? Besides Alan? Come on. Do we think the increase in yogurt sales caused a decrease in sherbet sales? Some people say yes, some people say no. I think the book says no. This is where, in first period, we kind of came up with a maybe, okay? You can write whatever you think is right, okay? I will tell you on the test, on the test review that is going to be just like the test, it's very clear. It's kind of like the mozzarella versus doctorate degrees, right? There was nobody that would argue with us about that. This one you could say a couple different things, right? They're both frozen desserts, so if more people are buying yogurt, less people are buying that. Some people might say, yeah, but they're two totally different, like, just because you buy more of one doesn't mean you buy less of another. So you decide which one it is. I don't really care that much, okay? All right, so that's what we're doing for number 2, and then 7 and 8. 1, 2, 7, and 8 are exactly like that. The other ones here are a little bit shorter. Okay. Do you want me to do another one with you? Does that help you? Okay. I feel like you guys are looking at me funny. All right, let's look at the next one. The table shows the average number, so you have to read. I mean, we have to read it. I mean, we can't just jump into these. It's not like, oh, I just pick up my calculator, type in the numbers. Shows the average number of minutes a person reads per weekday. Okay, so average number of minutes that you read, be my X values, and the average number of minutes a person watches television per weekday. And it's by age. Okay, so X's and Y's. We know X's are increasing, right? Now, what are the Y values doing? Let's see. We're going down, down, up, down, up. What do we think? Yes. why, so Alan, can I ask, you're right, I would call this increasing. Why, because it's really half and half, right? Look, guys, down, down, there we go, up. Well, we're going up a little bit more. But what made you say that? Do you have an answer for me, Al? Yes, that's exactly right. These are just slight decreases, right? We're just going down 2, down 2. But after 113, we jump quite a bit. So you can also think people that are older have more time to watch TV. I don't know, whatever. Who knows? But I would call that increase, okay? So we have reading, we have TV. If they're both increasing, it would look like that, right? Is there a correlation? Yeah, positive. And then you explain it as reading increases. I'm really making this short. TV watching increases. What do you guys think about causation? Causation can be kind of confusing. I'm looking at the key right now, because I don't know what the book even says about that one. I feel like you could make an argument either way. Right. So the book says no. Okay, they said there is no causation. Reading a book doesn't, no, that should definitely be no, right? Reading a book does not make you watch TV, right? If I read a book for more time, it doesn't make me watch TV. Almost you would think it'd be the opposite, you have less time. So no, the number of minutes spent reading does not cause you to watch TV more. Do you see what I'm saying? Yeah, just right now. So just getting you on the right page for this other type of problem. Does the correlation illustrate causation? So yes or no, does the one thing cause the other, and then give an explanation of your reason. A class experiment shows a negative correlation, so it's telling us it's like that, between the width of a person's palm and the amount of time they spend watching television all day. Does the width of your palm cause any kind of anything with watching TV? I mean, it's hard to even say out loud. It seems so silly, right? Alex, what are you doing? Does it? No. There is no causation. No. So you can just write yes or no for these, okay? So I'm going to just come around and check on you guys, see what you guys write, and then I will reveal some answers. Be quick. No, the clipboard. What did you guys say for 4? Yes or no? No, you can just say yes or no. Yes or no. So, okay, let's talk. I want to make sure you guys understand. Because these are going to be nice ones to do on the test, right? On the test next week, because this is just kind of almost like common sense. Larger person's shoe size, the higher person's reading level, right? Shoe size has nothing to do with your intelligence, so there's no causation. But if the price of cereal is increasing, that's your x-axis, and the sales are decreasing, that makes sense, right? So people are buying less cereal if the prices are getting bigger, right? So that would be yes. Yeah, Gabriel. Okay, I'm getting there. Kay, whoever that is, notices that the lower the daily temperature is, the less time she spends outside, right? So as the temperature, oh, that's weird. Let's not do a graph for that one. But it makes sense. The colder it is, the more you're going to stay inside. So that would cause. Temperature outside would cause you to stay indoors, right? That makes sense? Again, some of these are a little murky. The ones on the test, it should be very clear. If they're not, I will cut them like I cut so many other problems. Okay, don't let me forget about my